Hi all, let's go ahead and get started on our Module 5 test review. Now I am going to be working on problems 1 through 6. Examples A through F are yours for homework. They are due tomorrow. So let's go ahead and look at this very first one. I have a system of equations shown here, and I want to find the solution to the problem. Now I've focused on elimination, so I'm going to go ahead and use elimination with this. Although you can use substitution, like I said, I've just emphasized elimination for this unit. Now on this one here, I'm going to have to put them in standard form first. So I'm going to have to move this negative y over to the other side of the equal sign so that my variables are both on the left side of the equal sign. Now go ahead and rewrite this. Every chance that it asks you to rewrite something, just rewrite it. It takes a few seconds to write that down and less chances of making a mistake. So writing that in standard form, the second equation, or the B equation, is already in standard form. So I have 4x plus 3y equals 13. Now, I'm going to go ahead and combine these two. So I'm going to put our equal line down here. When I'm combining them, though, I need something to be eliminated. But 2x and 4x are not going to eliminate. And positive y and 3y are not going to eliminate. So what I'm going to have to do is I'm going to have to multiply one of the equations, and I'm going to choose to multiply equation A by -2. By doing that, I'll be able to eliminate the x values. So -2 times 2x gives me -4x. -2 times y gives me -2y, and -2 times 5 gives me -10. So that's equation A. I still want to combine it with equation B, and that one I don't need to change, so all I'm going to do is rewrite it. So again, rewrite them. Whenever they ask you to rewrite them or do something, rewrite it. Don't try to remember all those numbers in your head. Now we're going to combine these. So then -4x and +4x, that gets eliminated. -2y plus 3y gives me 1y. And -10 plus 13 gives me 3. So I have y equals 3. Once I have that, I can use that information to find the x value. Now to look for x, I can use either equation. Equation A, equation B, it doesn't matter. Most of the time though, we're going to go with equation A. So let's go ahead and use equation A. So I have 2x equals 5 minus y, and our y value is 3. Now I don't have any multiplication that I have to simplify. So I have 2x equals 5 minus 3. So that gives me 2x equals 2. Divide both sides by 2, and I get x equals 1. So my x value is 1. Y value is 3. Now because this is that ordered pair 1, 3, I know that this is one solution, and I know that this solution is consistent, independent. Okay? All right, so that's question number 1. That should help you complete question A. And now let's go on to question number 2. Question number 2 says a farmer counts 40 heads and 126 legs amongst his chickens and horses. How many of each animal does the farmer have? Let H represent the horses and C represent the chickens. Select which equations could be used to represent this situation shown above, or described above, I should say. So now we have our 6 equations here. Now a system of equations, we've used 2 equations. So that should give us a hint that we're looking for 2. Now I'm going to pretend that I'm covering up my answers here. And I'm just going to worry about writing the equations. If I know how to write them, let's go ahead and do that first. So the farmer counts 40 heads. That's the total number of animal heads that there are. Then he counts 126 legs, so that's the total number of animal legs that there are. Okay? He is counting chickens and horses. So if my totals are 40 and 126, we can use that to write the equations. Well, when I think about chickens, a chicken only has one head. Okay, a horse only has one head. But total, he counted 40. All right, now when we talk about legs, a chicken has 2 legs per chicken. And then there's 4 legs per horse. And the total legs that he saw was 126. Now that is the information I need to select my equations. So I have equation B, and then 2C plus 4H. Now I don't see that looking at it directly in that form, but I do see 4H plus 2C. So, because here I have 2C plus 4H, but that equals 40, and I need 126. So here I have 2C plus 4H. That one equals 126. So my answer is B and C. So now it asks, how many horses does the farmer have? Well, if I want horses, then I want to eliminate the chickens. Okay? So I'm going to have to combine these. But if I'm combining them, I want the chickens to go away. So before I do that, let's go ahead and multiply equation A by -2. So -2 times C gives me -2C. -2 times positive H is -2H. And -2 times 40 is -80. Now I'm still combining it, so I need equation A and equation B. But equation B is already the inverse. So I just need to rewrite it. That doesn't take me but just a few seconds to rewrite it. Okay, now let's go ahead and combine these two. So -2C plus 2C, that eliminates. -2H plus 4H gives me 2H. And -80 plus 126 gives me 46. Divide both sides by 2. And I get H equals 23. So how many horses does he have? He has 23 horses. Now, if I needed to know how many chickens he has, I can plug in 23, substitute 23 into either equation A or B, and I'd be able to find out how many chickens he has on his farm. All right, that's question 2. Let's go on to question number 3. Now, question number 3, Marshall and David work at a furniture store where they sell couches and tables. Last week, Marshall sold 2 couches and 3 tables for $6,000. David sold 5 couches and 5 tables for $12,500. So what am I comparing? Well, I'm comparing Marshall and David. What are my totals? $6,000 and $12,500. So what did Marshall sell? Well, Marshall sold 2 couches and 3 tables, and he made $6,000. And then David sold 5 couches and 5 tables, and he made a profit of $12,000 in sales, $12,500. Okay. Now we want to combine these, so I'm going to put the equal sign. Now, they're asking me to find the cost of 1 table. So if I want a table, then I want to eliminate the couches. So how do I eliminate the couches? Well, what can I multiply 2 by to make 5? And there's nothing that I can think of that's not a decimal right now. Then what could I multiply 5 by so that it equals 2? Well, that would give me, or I have to mean I'd be using a fraction or a decimal, which again, I just said, I don't want to use fractions or decimals. So I cannot eliminate them the way they are. But is there a number that 2 and 5 both go into that I can have one as a positive, one as a negative? Yeah, they both go into 10. So 2 times 5 would make 10, and 5 times 2 will make 10. If they were both 10, they would almost eliminate, but one needs to be positive, one needs to be negative. So it doesn't matter which one you make negative. I'm going to go ahead and make 2 negative. So this time, I'm changing equation A and B. Now I have 5 times everything inside this group. Now the second group, I'm multiplying everything by -2. Now once I have these equations, I can go ahead and combine them. So I'm going to eliminate the couches. And then I have 5 tables would cost $5,000. No, but I don't want to know 5 tables. I want to know just one. So I divide by 5, and I get T is equal to 1,000. So the cost of one table is $1,000. Okay, let's go on to question number 4. So here we have a youth group and their leaders visit Mammoth Cave. 2 adults and 5 students in one van paid $77 per Grand Avenue tour of the cave. 2 adults and 7 students in the second van paid $95 for the same tour. Which equation represents a constraint of the situation described? I'm not going to look at the answers. I'm just going to write my equations. I know I have 2 groups. The first group had 2 adults plus 5 students, and they had to pay $77. The second group that I had 2 adults, and they had 7 students, and they had to pay $95. It was easier for me to write my equations than to try to make sense of the equations and looking back at the word problem. Now that I have that, it says which equation. So that means it's just going to be one. So if I'm looking at the equations, A says 2A plus 7S equals 77. So that is not true. B says 7S plus 2A equals 95. That is true. Equation C says 2A equals 77 plus 5S. Well, if I move this 5S to the other side, it would be a negative 5S. So that one doesn't work. And D says A plus S equals 95. And that doesn't work because it doesn't have any price values. So my solution would have to be B. Or my equation would be B. Okay? All right, let's go to question number 5. Liam bought some book bags and pairs of shoes. Each book bag cost $13.75. Each pair of shoes cost $16.90. Altogether, he bought 12 items and spent $172.30. Which equations make up the system to determine how many book bags and how many pairs of shoes he bought? So here it sounds like I'm just looking for the equations. So again, I'm not going to look at the equations. I'm just going to write it how I know. So we have our totals are 12 items and $172.30. So of items, he bought book bags plus shoes, and he bought 12 items. Book bags cost $13.75 for however many book bags he bought, plus the shoes cost $16.90 for however many shoes he bought, and the total that he spent was $172.30. Now that I have my 2 equations, now I can go look at the answers and say which equations fit what I need. Well, the first one says B plus S equals 12. Well, that'll be equation B. My second equation is 13.75b, so I know it's not D, plus 1690s, okay, it could still be E or F, equals 172.30. So that means it has to be F. Okay? And that would be question 5. That's all they asked us to do. Now, let's go to our last question. Question number 6. A school sold tickets to both basketball game and a football game. Basketball tickets cost $8.25 each, and football tickets cost $11.50 each. In total, there were 215 tickets sold, and the school collected $2,102.75. Okay, so identify the constraints to solve this problem. Identify both constraints. So that means we're going to be looking for both equations here. Okay? All right, so I'm going to go ahead and start with what I do. I'm not going to look at any of the answers. I'm just going to look at the information and write my own equations. So the first one says it's 215 tickets. So I have basketball tickets and I have football tickets, and that equals 215 tickets. Now, the cost of a basketball ticket was $8.25 for the basketball ticket, plus $11.50 for the football ticket, and then we spent $2,102.75. So now if I'm looking for both equations, the first one would be equation A. The second one matches equation D. All right, what if they want me to solve it? Well, let's just talk about that. What if they're asking me to solve it? Okay, so I'm going to go ahead and eliminate something because they're both in standard form. I'm going to eliminate the x's. So if this one is positive 825, then this one needs to be multiplied by negative 825. Because I want to combine them, but I know that something has to be the inverse. So negative 8.25 times x is negative 8.25x. Negative 8.25y. Negative $1,773.75. Now the second equation has positive 825x, $8.25 per basketball ticket. And then positive $11.50 for a football ticket. And $2,102.75. Remember to put our equal line since we're combining these two. Negative 825 and positive 825x gets eliminated. Negative 825y and positive 1150y. That comes out to 3.25y equals, then this one here will equal $329. Now I'm going to go ahead and divide both sides by $3.25, and then I get y equals, now I'm just going to estimate here, but I am going to tell you that it is a decimal. Y equals 101.2, and then that number just goes on. Okay. So Y is talking about football tickets. So I have 101.2 some football tickets. Now my question to you is, can we buy 101 tickets? Yes. But in order for it to be equal, I need to buy 101.2 tickets. Can we buy that? No. So this here is not a good solution. Okay, this is not a valid or viable solution because we cannot buy a part of a ticket. All right, so that's everything on this review. Your examples are going to be 1 through 6. I'm sorry, A through F.